Alright, here is another example. They say two small identical spheres A and B are suspended on a long silk thread as shown in the sketch below. The sphere carries charges of this value and the other charge is that value. Then they say which sphere has an excess of electrons. So which one is excess of electrons? We know that electrons are carried by a negative charge and protons are carried by a positive charge. Electrons are carried by by a negative charge. And protons are carried by a positive charge. If they ask which one has excess electrons, you check which one has excess negative electrons actually. So which one is negative? Sphere B. So sphere B carries excess electrons because it's negatively charged. If they ask about protons, so sphere A carries excess protons because it's positively charged. So in this case, the answer is B. The two spheres are allowed to touch. Will the electrons be transferred from A to B or B to A? So electrons will move from negative to positive. So it's going to move from B to A. So our answer is B to A in this case. The spheres are now separated. So the moment you hear separated, you know which principle we're going to talk about next. So they say calculate the new charge. You see, separated, the moment they touch and they separate, you already go and fetch the formula for principle of conservation of charge because the two spheres are identical, therefore they're going to share the charge equally. So you're simply going to say Q net equals to Q1 plus Q2 over 2. So you choose between the two, which one is Q1, which one is Q2. Okay, let me write it this side. 10.3 Q net equals Q1 plus Q2 over 2. So we can say that Q1 is for A, which is 3 multiplied by 10 to the power negative 6 coulombs, plus Q2, which is negative 2 multiplied by 10 to the power negative 6 coulombs, divided by 2. So let's check what is the net change in the calculator. So the charge is going to be 5 multiplied by 10 to the power negative 7 coulombs. Alright. So now they say calculate the number of electrons transferred during contact. So during contact, the number of electrons, we know that number of electrons, we're going to fetch the formula for quantization of charge, which is we're going to take the second formula which talks about number of electrons equals to charge over QE, right? So our charge in this case, we're going to take the charge that we found here, which is 5 multiplied by 10 to the power negative 7, right? Then we're going to subtract one of the charges. It's either you subtract this one or that one. Okay, it's simpler to subtract 3 multiplied by 10 to the power negative 6, then over negative 1,6 multiplied by 10 to the power negative 19. Okay, so the only difference is at this point, the reason we are using two charges here instead of one is because this is a new charge. So now we want to understand the number of electrons which were transferred. So we're going to subtract the final electrons minus initial electrons. And that's the only case that we're going to use two charges. Otherwise, if we're only talking about one sphere, we're only going to use the charge for that specific sphere. Alright? So now the answer will be 1,56 multiplied by 10 to the power 13 electrons. And that's your answer. So you can calculate anything using the two principles. Alright?